Okay, in this video we're going to look at some rules of exponents. I'm sure you've all worked with exponents before, but just to make sure we're all clear on them, I'm going to run through a few of the rules and make sure we understand how they work because we're going to be using them throughout the semester. So first off, suppose we have this. Say 2 cubed times 2 squared. We want to know what that is and how the rules actually work here. But in this case, we can just solve it all out. 2 cubed is 8. 2 squared is 4. We get 8 times 4, which is 32. And now if I write that as a power of 2, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th. And now as far as rules go, if we have 2 cubed times 2 squared, if we multiply two exponentials together, we end up with 2 to the 5th, which is clearly just 3 plus 2. And that actually gives us the first rule we need to know. If you take any exponential, say raised to the m, and multiply it by another exponential raised to the n, you add the powers together. And we get a to the m plus n. Next up, suppose we have 2 cubed squared. In this case, you guys know the rules of exponents. We start on the inside of the parentheses and then work our way out. So if we do 2 cubed is 8. We get 8 squared. 8 squared is 64. And now again, if I want to write that as a power of 2, we just said 2 to the 5th was 32. Multiply that by 2, you get 64, so that's 2 to the 6th. And now as far as trying to figure out a rule here, if we raise an exponential to a power, 2 cubed squared, we end up with 2 to the 6th. That's clearly 3 times 2. So, if you take an exponential and raise it to a power, you multiply the powers together. So now, let's see. Those are the two main rules that we're going to use throughout the semester. There'll be other ones that will pop up that we'll look at, but those are the two main ones and the ones that people get the most confused on. But keep in mind, you can just pick a random number. Let a be 2 and make up some powers, and you can figure out these rules on your own. But next up, suppose we have something like this. Say 2 cubed over, actually we'll make this even more fun, 2 to the 5th over 2 squared. What happens if you divide exponentials? Well, in this case, let's see, on the top, 2 to the 5th is 32, we already said that. 2 squared is 4. 32 over 4 is 8, which is 2 cubed. And now again, we're kind of stuck with, how does this become this? Well, 5 over 2 gives 3. Sure, 5 minus 2 is 3. So there's my next rule. A to the m divided by a to the n is a to the m minus n. Just subtract them. But there are a few things that can pop up with this. Suppose we have, we'll stick with 2 again, 2 cubed over 2 to the 5th. Now just using the rule, this should be 2 to the 3 minus 5, which is 2 to the negative 2. And now we just need to know what a negative exponent is. But in this case, we can actually kind of go back to like 2nd or 3rd grade when you first learned about fractions. 2 cubed is 2 times 2 times 2. 2 to the 5th, I'm going to run out of room here, is 2 times 2 times 2 times 2 times 2. And now, like I said, go back to like 2nd or 3rd grade when you learn these. Cancel common factors. This 2 cancels that 2, this 2 cancels that 2, this 2 cancels that 2, and we're left with 1 over 2 squared. And now we see what happens with negative exponents. A negative exponent, 2 to the negative 2, is the same as 1 over 2 squared. So as far as that goes, we can use that as far as our tricks for exponents. If you have a negative exponent, we'll say a to the negative n is 1 over a to the n. If you have a negative exponent, just flip it and take the reciprocal. And now there's just two more things I want to kind of go over really quickly. Suppose we have 2 to the 0. What exactly is 2 to the 0 equal to? But we can actually use these rules over here to figure it out. For the sake of argument, 2 to the 0, suppose we have 2 cubed over 2 cubed. By definition, that is 2 to the 3 minus 3, which is definitely 2 to the 0, which we have right there. But 2 cubed over 2 cubed is 8 over 8, which is 1. And now again we see, if we have something raised to the 0, it's always equal to 1. Just using our rules right there. So we'll say a to the 0 has to equal 1. And now the last little thing. Suppose we have something like 2 to the, now we'll just make up some letters, a cubed b squared cubed. And I want to simplify that. As far as it goes, the rules over there say, if I have an exponential raised to a power, I multiply the powers together. Here I have more than one term, so all I'm going to do is distribute this 3 into each term and treat each of them separately. Just keep in mind, this 2 is separate from that a, so the 3 gets distributed to the 2 as well. So this becomes 2 cubed, a cubed cubed, 3 times 3 is 9, b squared cubed, 2 times 3 is 6. That's a 9, not an a. And now I suppose we can say 2 cubed is 8, so that's 8, a to the 9th, b to the 6th. This power gets brought into each term, including the 2. The 2 is separate from the a and the b. One more, and then we'll be done with this. Suppose we have 3a squared over 4b cubed to the 4th, we'll say. Who cares? Now I have a fraction, but the same principle applies. This thing is raised to that power, so I bring the power into each term in the numerator and the denominator. And I get 3 to the 4th times a, 2 times 4 is 8, over 4 to the 4th, b to the 3 times 4 is 12. And then if you want to simplify that, 3 to the 4th is 81, so it's 81a to the 8th, over 4 to the 4th is 256, b to the 12th. Ultimately, for the purposes of this class, these rules right here are really important, and this one will pop up a lot. These we will use occasionally, but they are important rules to know. Like I said, they will occasionally pop up, so we want to know them. But these things are really, really important, both for this pre-calc, as well as for trig and the future calculus, and whatever other algebra type classes you take.